Good afternoon. My name is Tony Ng, and we have Padma here with me as well. So both of us are from the eBay Data Services Platform team. And today we're going to talk about Experimentation Platform on Hadoop. Okay? So the Experimentation Platform is actually plays a very vital role at eBay. This is where we actually present different kinds of experiences to our users, and we will collect different data and figure out, okay, how each of these different experiences perform, and we can measure and provide insights in terms of how our users are reacting to the changes in our experiences. Okay? Our processing pipeline actually gathers a lot of this data, and we end up processing over billions rows of records on a daily basis. And from there, we are essentially trying to extract the different insights and metrics across many different dimensions. Okay? Over the last year, we actually went through a journey. A lot of these processing that I just talked about was kind of done more on a data warehouse kind of systems, right? Using SQL queries and transformation of the data. And we actually went through a journey of migrating a lot of that logic from a data warehouse solution into a Hadoop platform. Okay? So today we'll talk a little bit about some of the challenges and learning that we encounter while we do this migration. Okay? So agenda is pretty straightforward. So I would just kind of first give an overview of experimentation for those of you who are not too familiar with experimentation. Sometimes it's called A/B testing, right? What it is about. So give you some context. And then Padma is going to go a little bit deeper in terms of, okay, what exactly are the kind of data processing that we are going to do as part of this process, and talk about some of the learnings and challenges. Okay? So, what exactly is really this A/B testing? You may have heard about it. It's kind of being done in a lot of the internet companies, right, these days, right? And the goal really is to be able to present and compare multiple experiences to the group of users, right? And we want to know which one actually performs better, right? In a scientific and statistical, significant way, right? And when I talk about experience, it's not so much just limited to the UI, right? So obviously the user interface is one key aspect of the experiences that we want to test. But there can also be some of the back-end logic as well, right? Maybe different algorithms, like how we rank our search results, right? And how that change in the ranking might impact how the user reacts to that. Or it could be, different contents that we show to the users, right? So those are the different things. I'll give some example of some of the variations that we do. Now, in terms of measuring, right, when we say, which experience is performing better, right, how do we really, tell, right? And there are actually many different aspects of measurements that we do at eBay. It's not so much just limited to, okay, are people clicking more? I mean, that's obviously one basic metrics that we do, right? But that's also kind of more short-term reactive metrics, right? Depending on the goal of the experience, right, there are actually many different kinds of metrics that we measure. Of course, for commerce site like eBay, right, the ultimate measure is ultimately are people buying more things, right? Are we paying more, right? So those are one key measure. But there could also be other kinds of objectives, such as are they installing our eBay mobile application, for example, in reaction to some marketing messages, or are they decide to sign up, right, register their account, right? All these are potential outcome of the experience that we want to measure and figure out, which one is better. Okay, just two terminology, right? So typically when you talk about A/B testing, you would have something called control. So that is kind of, in a sense, your default experience, right? What we have like right now on the site is typically called control. And then you will have one or more treatments, right? So those are the variations, right? Maybe that's the next enhancement that you're trying to test and ship, right? And you want to do that A/B testing to figure out if this change is actually better or not. Okay. So, there's kind of two aspects when you do A/B testing, right? So first of all, there's the runtime component, right? And then there's kind of the data processing aspect of experimentation, right? So in terms of how we are doing it, right? So typically in a very simplified view, right? You have a big set of users, right, coming to eBay using our site or the apps, right? And what we want is to really, divide them up, right? There's a spectrum of users, and we want to, in a randomized way, right, try to partition the users into different, segments, if you will, right? And you want to do it in a randomized manner, right, so that, your test will be statistically significant and correct. So we will kind of provide different experiences to different set of the users, right? So some parts of that will see the control, some of them will see the treatments, and you could have multiple treatments at the same time. And there's a way to actually partition to users, so you can actually run many concurrent experiments at the same time, as long as they are kind of orthogonal to each other. So I probably won't go into details on that, right? Now, what's going to happen then is you are kind of collecting then all the activities that each one of these users are doing after seeing that experiments, right? So we are tagging each of the user activities with the particular treatments ID, right? So we're collecting all this raw data, and that's where then the next step will be the data processing part, which will be digesting all this raw log data and try to do different kinds of transformation, aggregation, so that you can see in aggregate whether certain treatments are, have a better conversion rate, for example, right? And the focus of our talk is more on the data processing side, right? There's actually a lot of interesting stuff on the runtime side as well, like how do you best randomize the user? There's different way to partition the users, et cetera, right? But our focus is more on the back-end processing part. Okay. So why is this important? So we really want to go about doing a data-driven kind of decision, right, at eBay, right? There's a lot of intuition, okay, maybe if I change the color, add the buttons here, maybe it'll be better, right, et cetera. But I think doing A/B testing is really the objective way for us to truly have something backed up by data, right? You'll be able to see whether some experience is doing better than the other, and it's not because of someone who has this very strong opinion about certain experience is going to do better. This would also reduce the risk in a way, right? Because you can test the experience against a smaller set of users and truly see how they are working, right? Before you roll out it to the entire site. Okay? So just to give some examples, right, in terms of different experiments that we have run. So here, right, you see kind of two different variations, right, left, right. There's actually multiple changes, but kind of curious, what do you think? Which one actually performed better for us? Okay. Left, right, okay, right, okay. So actually, the left one actually works better for us, and we do a lot of analysis, and in the end, what we believe is the watch. You see on the right-hand side, there's a watch button. And having that button actually create a choice for the user saying, oh, maybe I'll add this item to my watch list. I'll come back to it later, right? But in reality, they might forget about it and they don't come back to it. So presenting this option actually, lower our conversion rate instead of people checking out, okay? Here's another example. So this is kind of our recommendation module in a way, right? So they're showing similar products to people, right? So in this one, right, the right-hand side do better. So the difference here is really it provides a little bit more information, right, about the title of the product and the pricing of the product. So those are important information for the user to decide whether to pursue the recommendation or not. Okay. And just the last one, in terms of variation, right? Again, pretty similar UI, right? Which one actually do better? Right, so it's actually, again, the one on the right-hand side. And the reason seems to be, even though it's kind of have the same information if you look closely, right? But then, the one on the left actually is kind of this register. It's like the first button that they see. And a lot of people just got turned off by that. It's like, oh my God, I have to go through registration before I do anything. So, presenting the option allow people to proceed without actually signing in, actually allow us to get a better conversion again. Okay. So just some stats on eBay, right? So we kind of run over thousands of different experiments, many small aspects, different places of the site, from UI to backend. And we collect many different kind of metrics, right? As I mentioned, ranging from financial metrics to engagement metrics, right? And along different dimensions, right? Could be people, are they using mobile apps or different apps, right? Which geo region, right? So people might behave differently. And we want to capture all that as well, right? We generate over 300 terabytes of data per quarter, but to generate that amount of data, we actually process over 5x more of that data in order to summarize, aggregate, and generate that amount of data. Okay. So with that, I'm going to turn to Padma. She'll share more details on some of the processing that we do.
Oh, hi. So now that we have learned about experimentation, I'm going to go a little more deep into what we do with all the data that we collect, how this process is set up, how it's generating the data. So first, I'll quickly go over the life cycle of an experiment in eBay. So first, the product teams come with an idea. They come with an hypothesis. They want to test their hypothesis. So they come up with an experiment design, like how much traffic is needed, how long do I need to run this experiment, what are the factors that I want to test, how many variants I want to test, how many different variants I want to test, all that they come up with the design. Then they set up an experiment. There is a configuration tool for setting up an experiment. They go into the tool, they set up their experiment, they select the traffic, they select the treatments and all of that. Once the setup is done, it goes for a launch. The feature is up and live for the users to see for the selected percentage of traffic, and it's live. So once a user starts seeing the experience, we start collecting the information through the clickstream data. And along with the clickstream data, we have little more information about what kind of experiment they are seeing, what kind of factors they are seeing, and all of that. So that's the tracking part of it. And after we collect all the data, we start processing that data, that humongous amount of clickstream data, and then start producing the metrics, which will actually help the product teams to make the call to understand how the feature is behaving and how the users are behaving to that feature. So this is the experiment life cycle. I'm going to zoom into the last part, which is analysis and results, like how this data is collected, how it's processed, and all of that. So as I said, the user comes to the site, the user behavior or the clickstream data is collected. This approximately in eBay, it's 4 to 5 billion records per day. And it's like 4 terabytes of data. This information basically collects all the activity that the user is doing on the site. And then this information is taken, and then we do a series of process, and we generate a set of data sets called detailed data sets. The detailed data sets is nothing but from the ocean of data, we are just parsing the little informations that we need to generate the metrics that we want to analyze all those experiments and the features. So for example, a user is coming to the site, eBay site, he searches for an iPhone, and he does a lot of activity. He sees a lot of items he's interested in seeing. He's interested in certain items. He clicks on that item, he views that item, and then he does another search. Now he wants to look for a different a coach bag or something. And then all these activities are happening, and we are collecting all this. From all the activity, I am going to take only the set of information that is needed for this the process. This is the detailed data. Detailed data basically, as the name suggests, it captures all those detail level information. After this is generated, we merge this data set with some of the configuration information that we actually need, like what's the variant, what's the experiment, where is this experiment is, on which site, and all of that. So this is merged with the metadata, and then we generate something called intermediate data set. For example, this is actually a blow up of the data for the first detailed data set. So every action, need to be exploded to multiple experiments. On an average in eBay, a user is actually exposed to 20 experiments, different features we are testing. So they are approximately 20 experiments they are exposed to. So each and every activity the user does, we need to attribute that to all the 20 experiments. So in this intermediate process, we kind of explode that information. Every action the user does, we explode it to 20. Because at this point, we have to attribute this to each of that variant that the user is seeing. And then the final is the summaries. So now that we have linked all the activity to the experiment and the treatment, now I need to summarize all of that at the treatment level, so the product team can understand how that variant is doing. So here, for every variant, we calculate 100 plus metrics, and then that's actually in 20x dimension levels. So at all the 20x dimensions and the 10 layers of dimensions that we do, we calculate all those 100 plus metrics. And then that each and every metric, actually we generate 10 data insights like sum, mean, CI, p-value, standard deviation, and all of that. So once this summary is generated, the data is actually fed back into the BI systems, where we have MicroStrategy and Tableau dashboards to see those reports. And some of these data sets are actually loaded into tables. So there is a lot of ad hoc analysis, deep dive analysis is also feasible from this data set. So some highlights about what this data sets contain. As I said, each and every metric, we generate a different insights into that. Like every metric has an absolute count, normalized, lift. Lift is very important for experiment results, because you really want to understand how one variant versus the other variant is doing. So that's the comparison which will actually help to understand which is doing better. So lift is a very critical metric inside. And then standard deviation, confidence interval, and p-values, which will basically tell you whether the results that you are seeing is statistically significant. Can you actually go with this feature? I tested with the 5% data. If I go 100%, will I see the same amount of results with the 100% data also? See, this confidence interval and p-value basically give you that significance, saying that whether the results are statistically significant or not. So outlier capping. So we provide raw metrics and capped metrics. Outlier capping is nothing but any value that's above the normal. We do 99.9 percentile capping. So anything above 99.9 is actually capped, and basically that removes the bias from the results. So post-stratified is also another stratification adjustment method. This basically reduces the variance in the results. And some of the metrics, like Tony also talked about it in his, we generate different kind of metrics: transactional metrics, activity metrics, engagement metrics, and lot more. And as I said, we generate all these metrics at various levels of dimension, and various levels of dimensions. So we generate these metrics at the daily level, weekly level, cumulative. Cumulative is nothing but every experiment runs for 3 to 4 weeks. So we need to generate a final result, which is a combined results of 3 to 4 weeks of data. So all this humongous processing is what we do in this reporting pipeline. So as Tony mentioned, we were doing this in data warehouse till a year back. So when we started the Hadoop migration, I'll go over what was all involved in this, and then also talk about the current architecture that we have set up in Hadoop. So why Hadoop? I think this is like a no-brainer. The whole industry is moving towards Hadoop. So some of the benefits that you would get from moving from a data warehouse to Hadoop: cost efficiency, storage flexibility, scalability, all of this is like kind of known. But there are some certain benefits also that would apply for our processing, which was like we have more flexibility in design and development. We could use all those tools and frameworks that are built on Hadoop. I have more flexibility now to set up this whole pipeline. So in the data warehouse world, it's very tied to schema. Whenever there is a dimension change, when we add a new dimension to this process, or when we do any small changes to this data set, you need to do rebuilds of this large data sets. Work tables, target tables, all of that needs to be rebuilt, which is quite tedious. And code base also, there's any small change. We were running close to 2,000 SQLs, and any small change basically required making changes to all of that, and testing, and it was quite cumbersome maintaining that. So we wanted to overcome all of this, all of this in this new system. So this is a physical architecture of the reporting pipeline. So the user behavior data that's collected and stored in the Hadoop cluster. We use a scheduler to run all of our code base. Most of our code base is in Scooby and Hive. Using the scheduler, we use a job workflow and then start running all the process in Hadoop cluster. And as I mentioned earlier, there are some metadata and some transactional data information that is needed to enrich this user behavior data. That comes from MySQL and data warehouse through an ETL bridge, which is an homegrown tool that's basically connects the data warehouse to Hadoop. This information is also fed in this process, and then we generate the data, and it's fed back into the data warehouse tables, which is read by the BI tools and also used for further analysis and presentation of the results. So I'll go a little bit about some of the tech stack that we are implemented. So as I mentioned, most of our code base is in Scooby. Scooby is, as we all know, it's a Scala-based functional programming language, written in functional programming language. It supports object-oriented designs. It helps us abstract the MR framework code to lower, so that the developer doesn't need to worry about managing the mapper and the reducer code. And can be focused completely on business logic. And then it provides the typical data set operations like map, flat map, filter, group by, order, and all of that. And list is similar to the Scala list for the distributed system. It's a distributed list where it actually breaks into steps of MR jobs and submits on the clusters, enabling the user not to worry about writing a large amount of code, and basically gives you a concise code for maintenance. So this, I'm sure everybody must have seen this code. This is a word count written in native MapReduce, where you have to manage the mapper and the reducer part of it. And the same word count is written in Scooby, which is much simpler to handle and manage. So file format, when we were started this migration project, we were kind of doing some POC on what kind of file format is the right format for us. So we kind of picked the Avro format, which basically gives you the rich and complex data structures like maps and unions. And also the Avro basically has the portability in nature because the schema coexists with the data. And also it's pretty dynamic. It supports dynamicity by using the generic records. And ORC is something that we are kind of exploring now. The work is still on. For some of the processing, we are exploring to change the file format to ORC, which will basically give us more optimized data storage, and also help us in consuming less resources to read that more concise data. Hive. So Hive, there are certain part of the process which we chose to write in Hive because of we wanted to make use of that efficient joint nature. As some of our data sets, we need to do multiple joins in our data sets. The clickstream data, we need to join with transactional data. Both these data sets are humongous data sets. And for those kind of processing, we had a huge benefit in Hive. I'll go over some of this little later in the presentation. And Hive also gives us some UDFs which we could use it for calculating median and percentile calculations. And Hive Optimizer, as the Hive Optimizer actually makes the joins more efficient because it loads the smaller data into the memory as a hash table, and then the larger is scanned, which is much more efficient. And then it also automatically does map joins wherever it fits in. And Hive is not in the processing. Hive is also used for testing. Larger part of our testing and the QE work is actually done in Hive. A lot of reconciliation work is also done in Hive. So some fun facts about this processing. We read more than 200 terabyte of data at some points of this process every day. We run close to 350 MapReduce jobs daily, and we perform more than 30 joins using MR and Hive, which some of the data sets also have like data skew, heavy data skew. And we use 40 TB of yarn memory at peak time on a 170 TB Hadoop cluster. So on an average, we process for 150 experiments on a daily basis, and this whole process from end to end takes around 16 to 18 hours daily. A quick overview of this logical architecture. So when we designed this architecture, as I mentioned, we wanted to overcome some of the shortcomings that we had in our previous process. So configuration is key for us. As I said, this is something that we keep on adding more metrics, more dimensions, and we wanted to make the developer life easier. So we wanted to actually, we have extracted all of that separately, and we have any changes like dimensions and filters and new metrics, all of that is extracted so that it's easier for a developer to make those changes and not worry about making that change in each and every piece of the process. So that constitutes the configuration system, and then other framework components that actually is the caching and other utilities, the command line parameters, which actually helps us to tune the performance of the process. And other ancillary tools are like the logging and monitoring. We log all of this. We have logs that gives us more information about this process, and then monitoring at various places to identify failures and stuff. So challenges and learnings. A huge process moved from a data warehouse to Hadoop. A lot of challenges on the way, but a lot of challenges and a lot of learnings. But I'm going to focus on only 3 main topics, which is joins, and then some of the job optimization that we worked on, and how we dealt with the data skew. So key challenges, performance. Experimentation reporting is very key for eBay product, for all of the eBay product teams. So we have a very tight SLA. We have to generate the numbers, generate the reports, and so that they can make decisions on the launch of the features. So very closely tied to the SLA, and tied to SLA, and also heavily dependent on the resources. So performance is something that it's an ongoing process, ongoing job, a task for us. We keep on working on improving the performance. From 18 hours, we want to go lesser and lesser. So we continue to work on performance tuning, and I'll go over some of those in the next slide. Data skew. So some of the nature of the data has some skew, a long tail data distribution, and sometimes this causes a failure. If your process is not built to handle such data skews, it's going to either fail or have a very poor performance, and it's going to keep on running, which is again going to impact our SLA and then joins. So as I mentioned earlier, large data sets join. We had few challenges on that side, and I'll go over that. And then establish the job resiliency, just to make sure it's a huge process. We don't want a process to just fail and then wait for manual intervention. How we have done some auto remediation, alerts and monitorings, all that. I'll just go over that. The job parameters. So first, I'll go over some of the tuning of some of the parameters that we did, which actually benefited us in improving the runtime of the process. Sometimes it's runtime of the process, or sometimes it's the reduction of the resources that we utilize for this process. So we run concurrent jobs. So if you improve a job to use less resources, the other job is going to take a benefit of that and have more resources to perform and to process and run faster. So some of the parameters that we have done, that is split min size. So certain process, you want to make sure that your job gets the right amount of mappers, so that it'll process faster. And for certain data sets, if the files are too small, you want to make sure that the right amount of mappers are used to process it. So by actually tuning these parameters, we saw a huge reduction in certain process. So the range was about 9 to 35%. For certain jobs, we could see only 9% increase, but for certain jobs, we could see 35% increase in the processing time. And then the bytes per reducer. Again, at the reducer level, we tuned it to help to optimize the number of reducers that can be used. As I mentioned earlier, if our process uses a less reducer, the other process is going to take a benefit out of it. And then concurrent jobs, we want to make sure this setting up this parameter actually enabled us to multiple steps that can run concurrently. And then memory. So again, whenever the yarn container goes out of heap size view, we adjusted the memory, but you have to be a little careful with this parameter, because this is going to take out more resources, and you might not be able to run more containers. So caching, by establishing data cache for the objects, we kind of actually helped to improve the performance by 18 to 39% in some jobs. And also for certain jobs, we could see that cache hit ratio actually went over 99% for certain jobs. And then redesign and refactoring of the jobs. So we want to make use the parallelism. So some of the jobs we had to refactor it to run it earlier. So some of those joins and stuff, that if whatever that could run earlier and not wait for the process to complete. So some of those refactoring and redesigning we had to do, just to make sure that we have a better workflow optimization and more jobs to run parallelly. And then we had initially we were using a shared Hadoop cluster queue, which actually made us wait for longer times to get the resources required for processing. So we moved into a dedicated queue, which actually gave us a big benefit. So joins. As I said, there are certain data sets that have skew. There are certain data sets that are huge. So for example, a Warren Buffett a lunch or a dinner listing will actually get hit a lot of bids certain times it's hundred thousands of bits, which is basically a data skew. A regular item might have a very small number of bidding, whereas very high profile items or very high profile biddings like this will have a huge number of bids. So this is kind of a data skew. On an average, every listing might have like 10, 20, 50 biddings, but certain listings like this will hit a very large number, which basically makes the high data skew. So for those kind of use cases, we used the block join. We use the Scooby block join, which basically divides the skewed data into smaller blocks and joins the data block by block at a time. And we saw a huge improvement with this. And as I mentioned, there are a lot of joins that we do in this process to enrich the data. And certain data sets were like a few megabytes to even 40, 50 terabytes of data. And for these joins, we had a very poor performance using Scooby joins. So we did a lot of other alternatives, and we saw a huge improvement when we rewrite this joins in Hive. A certain joins which was taking like 6 hours was actually reduced to 2 to 3 hours in Hive. And when we did this process, we also tried the Hive bucket join, even though we saw a big gain in the bucket join, but bucket join requires the data to be sorted. And the sorting and the joining basically takes a much more time, so we didn't actually pursue that option. Combiner. So if the intermediate data set, when we saw in the workflow diagram, if you remember, we saw an intermediate data set which is an explorer data set that needs to be summarized into the final summaries of counts and means and standard deviation. So this is a big amount of data. And the reducers for some of the calculations, even for a simple mean, the reducers were not able to handle that amount of data. Certain times it's like 10, 20 millions of data, which reducer was not able to handle it. So if we came up with a combiner solution, which basically emits part values. It summarizes a part of values and does a computation, and for the same key using the combiners, which basically reduces the load on the reducers. So this, even though mean has like 2 parts, the combiner actually does the aggregation of both the parts and sends it to the reducer. And whichever pretty much any formula that has like this 2 parts in a formula can be used. The same calculations, the same way can be used for any calculations. Job resiliency, as I said, it's a lot of jobs that we run, and we want to make sure it's an 18 hours of processing. And we want to make sure that any failures has a way to restart. So we had set up auto restart in cases of job failures, and also monitoring and alerting on all of these failures, so that there is an immediate action to correct it. And then recon. So some of the data sets actually we want to make sure that from step 1 to step 2 there is no data loss, or there is no data corruption, or even for the data that's getting transferred from Hadoop to a data warehouse, we want to make sure that there is no data loss or corruption. So we set up a lot of recon and reconciliation scripts. Oh, I'm sorry. What did just happen? So while he gets the presentation back on, so next, what's next on our thing is we are exploring Spark for some of the process. We want to make sure that we get better benefit by moving to Spark. So that's something that that exploration work is going on. Spark is something that we are exploring. Certain set of process we want to get move to Spark. The presentation jumped back. Let's this is not the presentation. Sorry about that. So we are kind of close to the end of the presentation. So the summary is we had Hadoop. No, it's Hadoop migration was a huge benefit for us. Yes, we went through a lot of challenges and learnings, but we are getting the benefit of this framework and all of that. I think we could take questions right now while he figures out the presentation. Any questions? Yes.
Repeat the question.
Yes, yes.
Yeah, repeat the question.
So the question is, did we also consider scalding when we were considering considering this technical stack part of it? So yes. So initially we kind of compared Pig, Hive, and Scooby. Scalding also is very close to Scooby. It's a similar kind of framework. The reason that we opted for Scooby is in eBay we had an established Scooby platform, and which we wanted to make benefit from that. That was a primary driver to choose Scooby. Yes. Yes, as I said, it's still in exploration. We haven't done a lot of changes. We are still figuring out what is the right process to move to ORC. Yes. So as I said, so for certain process, we want to make sure that we get the right amount of improvement in processing. It's still in exploration mode. We haven't done any changes. So we are actually seeing Spark Hive. We're trying to see some of the Hive work and see if we could get a benefit on Spark Hive. We don't have any results from it. We just started work on that.
I think we should buy this.
Oh, okay. Thank you so much. Sorry we couldn't take more questions.